क्या है? What is this?
कॉम्बिनेशनल सर्किट और सीक्वेंशियल सर्किट है।
हाँ, यस, कॉम्बिनेशनल एंड सीक्वेंशियल सर्किट के बारे में है। तो you see there are two type of the digital circuits, and these are, first is combinational circuit and second is sequential circuit. Now the difference of this combinational circuit and sequential circuit, the first point is the output in combinational circuit, the output is instant response of input. Instant response of input. For example, suppose this is a circuit. This is a circuit, and here it is the input. So the output is your instant response. And in this case, the output is not only instant response, of input, but also the past status of the circuit. Past status is the important thing in this case. So we can suppose this is a circuit block, and you are giving the input. This is the input, and the output is after the feedback. This is your feedback after the feedback of the circuit. So the past status is stored in the feedback part, and then this feedback part is known as memory. This is memory element. This is the memory element. So what we draw here, in the combinational circuit, no need of memory unit. No need of memory unit. In this case, memory unit is necessary. Memory unit is necessary. Third and important is no need of clock unit. No need of clock unit. Here when there is a memory, so clock unit is necessary. Clock unit is necessary. So these are 3 points for the combinational circuit as well as sequential circuit. The examples, we have the very simple examples. Here the examples are first basic gate. Basic gate is something like OR and NOT. Universal gate like NOR, NOT, NAND, and adder, subtractor, etc., etc. Here, in the case of example, we can consider latch, flip-flop, register, counter, etc. These are the example of the 2 class of the circuits. Now, if you go for sequential circuit in detail, so we can have the diagram something like first combinational circuit, there must be a combinational circuit, then a memory unit, and then clock unit, then the clock unit. So this clock unit is checking the time factor of the memory unit, and this memory unit give the input feedback of the combinational circuit. So this is input terminal, input point, and here it is the output point. And this complete block is known as sequential circuit. This block is known as sequential circuit. So how this block is termed? The circuit changes its values. The new input values either leave the circuit in the same state or cause it to change through sequence of states as a result of the input change. As a result of input change. So circuit behave in this way is referred as to the sequential circuit. So this is the definition. You can say that the circuit change its value. Its value means the output value. The new input values either leave the circuit in the same state or cause it to change through the sequence of states. This is sequence of state because sequence of state means either it is 1 or 0 or 1 or 0 or 0, something like this. Whatever the state may be as a result of the input changes. The circuit behave in this way. In this way means something like the input control. If the circuit is changing, जैसा input में आ रहा उसके हिसाब से यदि circuit में output change हो रहा है, then we call it as the sequential circuit. Now the basic sequential circuit, that is the most fundamental sequential circuit, is termed as the latch. So we can have a circuit of basic latch. Now this is the important thing that we have to understand about the latch. And using NOR gate, latch using NOR gate. So before NOR, we know that there is a OR gate if there are two input, and then with this two input, say this is A and here it is B and the output is O. So 0, 0 is 0, 0, 1 is 1, 1, 0 is 1, and 1, 1 is 1 is the truth table of the OR gate. That is clear. What about NOR? NOR is as the circuit symbol. There is one bubble at the output, and suppose A is input, B is another input. So NOR input, NOR output will be, if it is 0, 0, then it is 1. If it is 0, 1 is 0. If it is 1, 0 is 0. If it is 1, 1, then it is 0. So this is the truth table of the NOR. So what we find from R to NOR, it's feel that there is a NOT gate in the output. There is NOT gate in the output. So in case of latch, if we take the NOR latch, then for the basic circuit of latch using the NOR gate can be drawn as how this one is. Suppose this is one input and here it is one NOR gate. Now this is another input NOR. This is another NOR. And here it is the other input. Suppose this is R. Later on it is known as reset. And here it is S. Then it is known as set. Set and reset. Then it is latches. What do you mean by latches? This is latch. This is your latch. This is the latch. If it is represented as Q, then this is Q bar. If it is represented at Q, that is Q bar. Q bar is complement of the Q. Now, we see the truth table. If you find the truth table, of this latch is, say, R, S, Q, then Q bar. R, S, Q, and Q bar. So, as we said, this is the memory element, means we can have the existing state. Existing state of what? R is 0, S is 0. If there is no voltages here, but in case of Q and Q bar, due to the memory, if the Q is 1, so Q bar is 0. Q bar is 0. If Q is 0, then the corresponding Q bar is 1. So here, these two are the existing state. Now, on the basis of these two existing state, in the NOR gate, we can complete this table. As, suppose this R is 0 and S is 1. R is 0, S is 1. So this R is 0. So for this case, that is, say, case 1. Case 1 is something like this. Something like this. R is 0. This is R. This equal to 0. S is 0. This is 0. So if Q is 1, say this is Q and here it is Q bar. If Q is 1 and Q bar is 0, so what the input, this one input is fed over the here. So it is 1. So S is 0 and 1. So 0, 1. So in case of 0, 1, the output will, in case of 0, 1, from the NOR gate, the output is 0. So this output is 0 value. This output is 0 value. And this Q bar is 0. So here it is 0 and 0. This value, 0 and 0. Both inputs are 0, then output will be 1. So this output is 1. Now the existing case can be differ as yes, this R is 0, S is 0, both are 0, but the existing state Q is equal to 0. If Q is equal to 0, so this 0, here it is 0. So S 0 and Q 0, both inputs are 0. then output will be 1. Output will be 1, and that is Q bar as well. Q bar as well. So if you take this one, that is Q bar is 1. So this is 1 and here it is 0. 1 and 0 is equal to 0. So if you take Q is 1, so this case is here, Q is 1 and this is 0, Q bar is 0. And this case, that is Q is 0, this Q is 0, then Q bar is 1, then this case. So both existing states are discussed in the case 1. So in this case, either of the 0 will give the same, as they give this same case, and here that is, you see once again, what we want to discuss in this case, 0, 0. If input is 0, 0, this is 0 and this is 0. Q is 1 and Q bar is 0. Q is 1, Q bar is 0. So here Q is 0, so this value is 1. The second, you can say this is the NOR gate 1 and this is NOR gate 2. This is NOR gate 2. So NOR gate 2 and NOR gate 1. So NOR gate 1 is 0, 0 here. NOR gate 2 is 1, 0. So 0, 0 give the 1 and 1, 0 is 0. This is clear from this NOR truth table. The second part is, this is 0, this is 0. What the change is? Q. Now Q is 0. So this is 0 and S is 0. Both are 0. So both 0 makes it is 1. And if it is 1, then 1 and 0 is 0. So this case, that is the both inputs are 0. Both inputs are 0, but the output will change, and this change is referred as existing state. So this one is the case 1. Case 1 we discuss here. Now for case 2 is R is 0, S is 1. So we take the case case 2. This is R and this is 1. So R is 0, here it is 0, S is 1. So if S is 1, that is the new state. So whatever the connection is, you see the connection is something like this. And this connection is basically known as latch. Latch is something like कुंडा जो बंद करने के लिए यूज किए जाते हैं, उस तरह से है. So this is Q and here it is Q bar. So S is 1. So any input of the value is 1, then output will be 0. It is very clear. The output will be 0. And here it is 0 and 0. 0 and 0. So this output is 1. This output is 1 and this is 0. So this is the case number 2. What is the case 3? In case 3, we can have the circuit something like this. This is NOR 1. Here it is NOR 2. The inputs are R and S. Latches are something like this. These are the latches. Here it is Q and this is Q bar. Now, in this case, the R is 1 and S is 0. R is 1, S is 0. So one of the input is 1. If the one of the input is 1, so the output will be 0. If the output will 0, so here it is 0 and 0 is 1. 0 and 0 is 1. So in this case, you find whatever the value of Q is, the Q bar is complementary of Q. So in this case number 2, Q is 1, Q bar is 0. Case number 3 said Q is 1, 0, Q bar is 1. So you see this 0 and 1, here it is 1 and 0. Case number 2 is 1 and 0. This is 1 and here it is 0. Case number 3 say it is 1, it is 0 and 1. It is 1. And the last case is case number 4. Case number 4. In case number 4, we see this is NOR. This is NOR. This is NOR. And these two inputs are, this is R. R is 1. And this S is 1. R is 1, S is 1. So these are the connection of latches. These are the connection of latches. Here it is Q and this is Q bar. So if R, any input is 1, the output will be 0. So in this case, this is the 0. So Q and Q bar is 0. So both inputs are 1. Then Q and Q bar is 0. Then this kind of the condition is unpredicted state. Unpredicted state, that is, you cannot say this is the unpredicted state. This is the unpredicted state. So if we quickly observe the table that we can drawn from this, here it is R, this is S, this is Q, and here it is Q bar. So what we find is 0, 0, so irrespective, if it is 0 or 1, then it is 1 and 0, then it is called existing state. Is existing state, and the existing state is identified by the memory element. This is identified by the memory element, what kind of the state is there. So now the case when this one is 0 and 1, this is case 1 output, here it is case 2 output. Case 2 output is this case 0 and 1. So what we find, this Q is 1 and Q bar is 0. Case number 3 is set, here it is 1. This case R is 1, S is 0. So 1 and 0, the output is 0 and 1. The output is 0 and 1. And case number 4 is 1 and 1. If both the inputs are 1, the output will be always 0. So what this case indicates? This case indicate is unpredicted state. Unpredicted state. Sometimes it is also called don't care state later on, but here it is, we can say it is the unpredicted state. So this in this way we can have the basic circuit of latch using NOR gate. Now we can have the time, we can have the time factor, that is how the time graph can be used to explain. So the time graph is important, and this time graph is something like, if we have the time slot, so we take this one is 1, 2, 3, 4, 5, 6, 7, 8. These are the time slots. So say this one is T1, this one is T1, this one is T1, this is T2, this is T3, this is T4, this is T5, this is T6, this is T7, and this is T8. There are 8 time slots, and in the 8 time slot, we say the value of R value is 1 and 0. R value is 1 and 0. So it is 1, and this is 0 state up to the T4, and this one is 1 state up to the T7, and then this is the 0 state. So this is the input R, and for the S, input S is, this is 1, and here it is 0 state up to this point, T2, and then T2 to T3, it is 1 state, and then this is T5, and then it is the T6, and here it is T5, and then from T6 to T8, this state. This is the input. Output is Q state. You see the output. If both S and R, you see, case 1, what was the case 1? When R is equal to 0 and S is equal to 0. Both are 0, that is existing state. Or sometimes it is also called as complementary state. Complementary states, either it is 0 or 1, or 1, 0, and this one is in between T1 to T2. This state, it is 0, and here it is 0, 0 to 0. So this Q is, this is 0, and this is Q bar. Q bar is 1. This is 1, 0. This is 1, 0. This is 1, 0. Then the state is, Q bar is this one. And this value is so these are the variations of the output. This is Q and Q0. So case 2 is S0 R1, then it is reset. Case 3 is S is 1, R is equal to 0, then this is set. And case 4, S is equal to 1, R is equal to 1. So unpredicted state. Unpredicted state. So these are the time graph. These are the time graph